I would like to tell you all a little story about how we built a component library in Angular. And this library allows us to take an excerpt of code that forms a piece of an application, such as a table or breadcrumbs or a dialogue, and reuse it in multiple projects, which are maintained by separate and partially autonomous teams. And we'll talk about the architecture we've chosen, the techniques we use to execute these ideas, and the lessons we've learned to help you, hopefully, get a head start for your team. First of all, a little bit of context. I think it's appropriate. My name is Coen Koopmans, and I'm the lead front-end developer of KPN's Grip team. I've been working as a front-end developer since 2010 now. Oh, how time flies. First at some smaller internet studios, and now at KPN since September of 2017. I've had the lead role for almost a year, and before all of that, I studied interaction design, which means that I'm always looking, well, not only from a technical perspective, but also from the users. I like object-oriented programming, functional programming, and I really love how Angular allows you to blend the old and proven and the new and exciting to allow you to form a way that really works for you and your team. And for us specifically then, I guess. I think for development, for me, maintainability is key. Not making code very fancy. I don't like making code all too fancy. I like making it readable, maintainable, making sure that you and your colleagues can still understand what you've written and why in half a year or a year from now. And speed as well. Speed is great. Another small piece of context, I won't keep you too long. KPN Grip. So what is this? Well, it's an identity management platform which allows you access to all your business applications. Or, well, single sign-on. I guess you could use it for other stuff as well, but it's mostly used for the business market. Over 20,000 companies in the Netherlands are using Grip in some way or another. And it's very focused on security. We have all of our data centers in the Netherlands, so nothing can go through the US or through the NSA or whatever. KPN is very strict about this stuff. They give us a regular penetration tests and audits, and we have to conform to the ISO standards for web security, etc. And the cool thing is that you can, well, all of the stuff that corporates really love, right? Active Directory, making sure you can set your own security standards, and that's what we're really focused on. And what I think is very neat about that is, of course, that's very back-end and very technically oriented. And that gives us great flexibility and great opportunity to make a neat front end on top of it. And that can make a big difference, I think. So, that sounds simple, right? So far, so good. But of course, we're in the corporate world here, and it can never be simple. The scale of our product has somewhat increased since the start of 2018. Mijn KPN Zakelijk, my KPN business corporate, I'm not sure. Nobody ever really made a hard conclusion on the translation of that name. But Mijn KPN Zakelijk was a loose collection of legacy portals, some of which stemmed back all the way to 2006 or even earlier. And that's all to manage stuff like corporate telephony, internet subscriptions and stuff like that, you can imagine. And they needed a safe space to plug in some new pages that could replace those portals of old. And instead add on to Grip. But since their purpose is so differently aligned than ours, they're working on something which is pretty damn different, we decided to create a separate team for them altogether. And thus a new way of working was founded. And soon, 2 more teams joined suit. One for self-care for corporates, which is kind of the same thing, but not totally, because I guess larger companies pay more and get more attention or something. And one for displaying a myriad of information in simple widgets on the Grip portal homepage. You can log into other applications, but we also have a portal where you can configure everything. So how do you work together effectively with those teams? And we decided to use the Spotify tribe model. We have 4 teams, like I said, that are working within this same tribe. I don't know if many of you are using this as well, but small review. So they're working on the same product in a sense, on Grip, but focusing on different services or even more and more microservices within. Each team within the setup is a squad, and they report to their own product owner. And those product owners have a bi-weekly meeting to align themselves, to make sure they're on the same page. And members within the different squads of the same role can form a chapter, like back-end developers and testers, and front-end developers. And that's where my role as a front-end lead comes in. And those chapters also regularly align themselves with bi-weekly meetings. So that's great, right? Because those teams can each be focused on their own goals, but still work toward a common end. But there are also pitfalls and other dangers lurking in the night. For I have seen with mine own eyes the horrors of inconsistent UI design, doing work that's almost the same in a totally different way, and the difficulty of aligning development techniques. The key here, I think, is the amount of autonomy granted to each team. Because give too little, and they'll be annoyed having to check every single little thing with you all the time. Well, of course, you're not as invested in their product as they are. And that'll make your work a lot more like that of a manager, and that's not what we were going for, at least. Might work for some other people. Give them too much autonomy, and they will each think of totally different solutions to the same problems. For example, they will probably create table components which mostly look and work the same, but not completely, leading to a number of different problems, such as difficulty in pushing updates in the look and feel across the entirety of the application, looking at you, Windows 10. Sorry. Doing work that didn't need to be done twice or even more often, and some subtle differences in the way that the UI reacts that's not always explicitly designed for. For example, when you have a table, and you can, this is a very stupid little example, but you have a sorting header, right? And you have this little arrow that shows you if it's sorting in an ascending or a descending way. It's ascending, you click on the sorting header, it goes to descending. But designers almost never design what happens if you click on it again. Will it reset the sorting to the default from the back end? Will it go back to ascending? It's a small little thing, but I think you can get the point from this. Different developers might implement it in a different way. And the users really don't care about these differences, like this team makes this part of the product, this team makes this part of the product. They just want a consistent application that reacts in a way that they expect, or they get frustrated. And the solution we came up with for this is to create a component library to which each squad contributes. So it needs something new, something extra, something that's not inside one of these components already. Well, you can add an option to you can add a new add input decorator. You can have a config object in an add input decorator and expand the interface for it to support more options. Just make a pull request, right? Assign an experienced developer from each squad. Don't wait for people who are gone for multiple days, because that will just slow you down. You're so bogged down in the process that you're forgetting to deliver code. Each component needs to be individually versioned to make sure that the squads are not forced to update the component in the same sprint. Maybe the sprint for us is 2 weeks. Maybe halfway through the sprint I update the component in a major way. And if it's not versioned, and I made some major breaking changes, then one of those other guys would be forced to immediately fix all of that stuff, while they're also trying to get to their sprint goal, right? So versioning is very important, especially for breaking changes. And shared linting can be a big help in enforcing that you all write code in the same way. This usually helps not only for semantic reasons, and with semantic reasons I mean like my code is poetry, like it reads like a poem, trying to get beauty out of it, but that's not the point. I think the point of linting and of the same standards is to help other people understand your work, and to help everyone understand each other's work more easily. And after you get used to the linting, and after you get used to the pull request comments, we've noticed that people will start to write more similar code more easily, and less pull request comments are necessary. And that increases maintainability because, well, sometimes people go on holiday or leave the team, or we transfer a project from one squad to another. And of course this also brings some new challenges to the table, mainly for deciding who does what and when. Everybody wants to help, sure, but they also have their own team goals. And luckily our Scrum Masters help us weigh these stakes, but it's not always an easy challenge to overcome. Okay, so the component library is the solution that we want to go for. So what do we need? Well, something to package Angular projects. You cannot simply paste another Angular project into your environment and expect it to work. And that's of course mainly because of the way that TypeScript imports files, but it would also be wildly impractical to copy and paste another project into yours every single time a new version comes out. And what would happen if your project is running a slightly newer version of Angular than the other one that you're importing into it? That can lead to all sorts of problems. And we need a way to publish and share and version all those packages, because it would, again, not be practical to just paste the component into our own every time. We want to be able to work through NPM, right? Just like we're used to with Angular itself and with all of the other JavaScript ecosystem stuff. Architecture. Well, we need an architecture for the component library itself, because, well, it needs to be a project in its own right, or multiple, I guess. Where else would you store your files? How else are you going to run your unit tests or your other automated tests? And documentation, because the best library in the world would not be the best library in the world if its documentation were lacking. Other people need to know what's going on and why. And moreover, you need to know what's going on in a few months from writing a piece of code. So, for the packaging, we found this great little tool, ng-packager. And this nifty little tool, I really have to read this carefully, will help you build an Angular library from TypeScript sources and create a distribution-ready NPM package, as they so eloquently put it themselves. So they take your code and transpile it to the Angular package format. This is not something you probably want to do yourself, as it is very complicated, the format. But luckily, using the tool is not very complicated. You just install it, and then you add an ng package property to your package JSON file, and you specify where your public API file resides. And the public API file just explicitly exports all of the files that you wish to be public. So you just re-export all the export from the other files, right? Export class this, export interface that. Well, you re-export it again, and that gives you great granular control over what parts you want to be publicly available, just like with public and private methods in a class. And that's very nice. And then you just run the ng packager command through a package.json build script. You can also choose to make it more complicated and change the angular.json file to run ng packager on a per project basis instead, which is what we did eventually. And this allows you to simply run ng build for a specific project. It also allows you to create a separate file with the ng packager configuration inside. So, we get our distribution folder, which includes this complicated Angular package format all done for you. Maybe you can kind of see what I mean now with not wanting to do this yourself every time. So what now? Oh, we'd like to publish it on NPM, of course. But our company policy does not want us to publicly publish this type of code all the time, especially in a security-related product that might not be the best of ideas. And I bet the same goes for many of you. And there are a number of options for publishing the package. You could just link to a Git repository with SSH, with a branch or tag reference, which is what we started with, sadly. However, this makes for a very annoying process, because after building, you need to get a branch or tag on Git to contain only the distribution files, and none of your sources in order for the packages to work properly, or do something complicated and strange with importing. Just using NPM seems better to me then. There are a number of private NPM solutions, which are basically creating a proxy of NPM for you to talk to. So you configure your machine to talk to the NPM repository, and it will talk to the normal public NPM whenever you need it, like when you want to update Angular or something. Install another generic package that's in the public repo. And some of these are cloud hosted, such as the solution that NPM themselves provide. There are different ones available as well. But we prefer Verdaccio because it allows you to self-host. So Verdaccio, apparently it references the color green that you see there, which was apparently often used in the Renaissance. Wow. So you can use Verdaccio to, well, self-host and publish your packages. And you can also make overrides to packages that are already in the public NPM repo. So maybe you find some bug, and maybe you're being a good citizen of the JavaScript world, and you're helping those guys by making a pull merge request on their GitHub page, but they have not accepted it yet, or it's no longer maintained or whatever. You could fork it and republish that again, but with this mirror, you can very easily just override a specific version, which can be a very great solution if you are short on time. Very cool stuff. So, after getting it running, just follow the documentation right, all you have to do is follow the instructions that are displayed on the public site header, like you see up top there. npm set registry, and then the URL where you're hosting it, and then npm add user -- registry, and again the URL where you were hosting it, which adds your user to there and enables the proxy thing I was just talking about. Authentication can be done in a number of different ways through plugins for Verdaccio, such as the default htpassword method, OAuth, Bitbucket, or the one that we use is Active Directory, corporate, like I said. You can only see the published packages, their versions, install and publish, and all that good stuff when you are logged in and authenticated. But of course, that's all configurable. You can set up roles and whatever. It can be as simple or as complex as you like it to be. Well then, now we just published the distribution folder that came out of the build just now. And after refreshing, the package, or the new version of the package, will show up right here in Verdaccio. The architecture ingredient, well, we wanted to be able to version every one of our components separately, so they needed to be distinct projects. But making a separate Git repository for each of them would be, well, a big hassle, frankly. We would have to implement the library architecture many times, including the linting, building, and testing parts. It's also just a bunch of repos which make your life just a little bit harder. So we thought we'd try out the mono repo idea that's been floating around for the past few years, where you just have one repository, which we dubbed Grip Core FE. We would have called it Grip Core, but the backend guys already reserved the name. Shuts. This one repo contains multiple projects, which are all the ones displayed in the slide, as well as a demo library of sorts to serve as documentation, which we'll get to later. And of course, Angular easily allows you to set up a monorepo structure by using the Angular JSON file and specifying multiple projects inside. And we always try to stay as close as possible to the Angular tooling, like the CLI, as we can, because why make it harder for ourselves by configuring Webpack manually? Good luck debugging that stuff, man. The core project contains a lot of miscellaneous stuff that just didn't seem right to give their own project. That's why all the arrows are running there, because, well, we have our own extension of the error class, which you can use for logging, piping everything to logs, stuff for theming, utilities, all that kind of stuff. And other projects can make use of that core, but not the other way around, because we're afraid it would become a tangled mess if that was possible. So you pretty much when you use this, you always need to import the core module eventually, and any one of the parts that you wish to use in this specific scenario. So how is this structured? How do we run unit tests? Well, as is often the case in life, it's pretty simple when you have the answer, right? At the top level, we have the demo folder that you can kind of see over there, and the projects folder, which contain the actual components inside of the library, the ones that you saw on the slide just now. These have a source folder inside and their own package JSON files. The last bit is important, of course, the own package JSON files for each separate project. Because Verdaccio will publish your components based on the name and version provided in the package JSON file. That's the NPM way of working, right? We chose to prefix all of our stuff with @kpn-grep/, as you can see in the top left again. You see the top level package JSON has not been edited in quite a while from the name and description, but that's not as important. And because all of the projects and their build settings are defined in angular.json, we can easily kick off builds and tests and everything from either the top level or from a specific project, which is very nice. You can see that tests, colon, piece, dash, whatever, it's an entire line. So if you do npm run test, or npm test or whatever, then do the npm run all thingy and it will go through all the test things. So it first builds all of the projects and then it runs the unit test for all of the projects, which is nice for Jenkins. But you can also go to a specific project and just run the tests there, for instance, when you're debugging one of the unit tests, because they're like houses of cards. So, now that we've got almost all of the ingredients ready, let's review the publishing flow. Well, step one is the version. Move to the directory of the project that you wish to publish. You could change the numbers of the version in the package JSON file. A foolproof, easy way to do it instead is just to run npm version major, minor, or patch, right? This will increase the semantic versioning number accordingly, where the first number is the major version, the second number is the minor version, and the third is for patches. If I only change something to fix a bug and I want to release a new version, that's a patch. If I add a new feature, it's minor. And major is reserved for breaking changes only, if somebody else would have to change something in their code to keep on using the component as it was. And whenever you increase the number on the left side, it will reset the ones to the right. So we have version 1.2.3 in this example, we go to 1.3.0 if we increase the minor version. And this, along with keeping a change log or documentation, will be of great help to those using your projects. Now the second step is a lot simpler and shorter, build. It's pretty simple, run the build command. And the third step is to publish. So make sure you publish the dist folder. Stuff will go horribly wrong if you don't. Either change directory into the dist folder and type npm publish, or just do npm publish dist instead. We have had many issues because of publishing the top level of the project, including all of the sources. So we're almost there. Woo, we've published. So now everybody can check out your package whenever they want, pun intended. But how do they use it? Well, first of all, you'll have to install the package as you would with any other npm module. Then you just import, just like with Angular itself. For instance, you could say, import grep tabs module from @kpn-grep/tabs. Remember all that exporting through the public API file earlier? Well, all of these exported variables, classes, and interfaces, and so on, can now be imported through this method. So whether you need to import an entire module or just an enum, you can all import it just like that. And you can take that idea pretty far. You could even extend an abstract class, as we did on the left here in the example. You could extend the abstract class from one of your components in the core project, pass the dependency injection constructor arguments through the supercall, and easily create similarly looking pages inside of a project, which is exactly what we did here, because we have many pages where you just see a table with a list, especially for all the technical configuration stuff for administrators. A list, a table, you want to click on an item, then you go and configure it. And that one, well, repeats itself pretty often, which have different API calls every time, which is where this comes in very, very nicely. One thing to keep in mind, everything exported lives on the top level of the namespace. You could try to manipulate the export file to export stuff within namespaces, and Lord knows I tried, but it just caused a lot more problems. So, I don't know, send me an email if you figure it out, but otherwise, try to keep the components small enough that you don't have any namespace conflicts and everything can simply live on the top level. Downside, of course, is that you're going to get longer names for your classes and stuff. So if you have a table component, you cannot have another table component within the same project. The last ingredient on our list is the documentation. And we chose to provide documentation in two flavors: the README and changelog files for each project, and a demo library. The library is nothing too fancy. It's just to test out the components that you're working on immediately, like you normally would with any Angular project, before you publish it. But keep in mind that it's important that people know what you've been doing and how to use it. And the most important thing about documentation, though, I think, is that it's a double-edged sword. Because it's nice to be able to read how stuff works and why, but it's also kind of a hassle. Nobody likes to read, right? You've seen that often enough in the real world, probably. Code should be self-documenting wherever possible, but that's, of course, a different subject. To finish it up, I'd like to share a few things that we've learned, some best practices, if you will, to help you get along. Separate projects for every logical, semantic grouping of functionality. Well, so what I mean is, if your table component is also starting to contain search functionality, it might be a good idea to split them up and create a search component inside of your library as well. Because who knows when you need to use search again. You might need it again. Try to keep the components small. Because of the namespace conflicts, because of the significance of the versioning, because otherwise you're pushing major versions when only a small part of the application has a major change. And also because of, well, just creating an environment that kind of feels nice to work with. You're doing this every day, right? Don't let other teams, other squads fall too far behind is another important one. Because you can publish all the versions in the world that you like in trying to keep the UI consistent between all the parts of the application. But if one squad is pushing all these updates and installing all these updates, and one of the other squads is totally not doing that at all, you're still going to have divergent UI, which is not solving one of the original problems. And that's not good. So make sure that all the teams regularly take time, make sure that's part of your planning to update all of the stuff. Publish the documentation and demo pages on easily accessible URLs is another lesson we've learned because, well, it's just kind of a hassle to just pull all the latest commits and start up ng start and whatever, just to see how some simple thing is working in the demo documentation page. That's a hassle, just put it on an easily accessible URL for you. Don't publish the source folder directly, it will lead to problems. I'm just repeating this because we ran into it so many times. Oh man. If you forget to pull the newest commits into your version, you might end up going back in time. Because maybe you've published version 1.5.3, but somebody else already went to 1.6.0. And that kind of stuff will lead to major headaches. Avoiding it by checking on Verdaccio what the newest version is and making sure you pull all of the commits before you start creating a new version. And yeah, test locally before you publish. You can copy sometimes because, well, it would be nice if every single edge case and every single detailed thing was inside of the demo documentation page, but at one point you have to make a decision like, is that worth my time really? What you can also do before you publish and install and all that stuff is, well, build it and just copy and paste it into your node modules folder to check out some obscure edge case and to fix that instead. It does take quite some time though, and it's a hassle again. And personally, I chose to create a Mac automator script that will ask which core project to copy and to which repository to copy it. And the last one is you can still debug published packages through Chrome search, which is very nice. Is this maybe a little bit small? But you can see at the bottom there, if you search for table component, it can still find it inside here. You can still set breakpoints and still look inside, and that will help you a lot with debugging this kind of stuff, especially for edge cases. One of the things we have is a form abstraction tool. And well, you can imagine that there's a lot of edge cases in that thing where specific bugs are very difficult to track down, and this is a major lifesaver. And really, that's all I wanted to tell you. Thank you so much.